Yeah, all good. Great.
You know,
What?
my roommate's going out of town tomorrow, so if we want to come back here after Erlich's party.
Oh, okay. Yeah, sure. That sounds good to me.
All right, it's a date.
See you then.
Richard, what's wrong?
Nothing. Nothing. Literally, it's all good. Come on.
Oh my God.
I'm sorry.
Your roommates were right. You really hate spaces.
No. I don't. It's not hate. Hate's a strong word. Truth be told, I do have a slight preference for tabs, but that's only because I'm anal and because I prefer precision.
Well, not to pick a fight here, but if you really care about precision, wouldn't you use spaces? But whatever. Once it goes through the compiler, it's the same thing, right?
Yeah, technically, yes. I guess I just don't understand why anyone would use spaces over tabs. Like, if it's all the same, well, why not just use tabs?
Because it could look different on other people's computers.
Tabs create smaller file sizes, all right? I run a compression company. Trust me, I've devoted my life to minimalizing file sizes. It's what I do. I mean, I do not get why anyone would use spaces over tabs. I mean, why not just use Vim over Emacs?
I do use Vim over Emacs.
Oh, God help us. Okay, you know what? I don't think this is gonna work. I'm so sorry. I mean, like, what? We're gonna bring kids into this world with that over the heads? That's not really fair to them, don't you think?
Kids? We haven't even slept together.
And guess what? It's never gonna happen now because there's no way I'm gonna be with someone who uses spaces over tabs.
Richard!
Wow, okay. Goodbye. One tab saves you 8 spaces.
Oh my God. Richard, what happened?
I just tried to go down the stairs 8 steps at a time. I'm okay, though.
See you around, Richard.
Just making a point.
All right. That's the weird thing about using YouTube. Probably not a good idea. Hello, everybody. My name is Bas, and this is a talk about TypeScript. Thank you for waking up so early in the morning and coming to watch this talk. Before I begin, how many people here use JavaScript for their day-to-day job? Please raise your hands. All right, a lot of you do. That's good, because this talk is for you. How many of you use a transpiler for your JavaScript? Nice. How many of you use TypeScript as your transpiler? All right, so good audience. How many of you use spaces? That was a joke. So I use spaces, by the way. Tabs was a joke. The thing that I want to make very clear in this presentation that TypeScript is just JavaScript. I've been told that I need to stay here to be in the video. And essentially providing a better initial experience when you start using JavaScript. Because JavaScript is not a perfect language. We all understand that. It has a few what's stuff that makes you go like, what? Instead of like having nice cats and horses being in harmony, cats purring horses, you get stuff like, what? JavaScript has the concept of errors. Like, I'm sure we've all seen something like this happen to us, where you call some function on something, and it does give you a nice error that this thing doesn't exist on that particular object, and we get nice stack traces as well, so you know exactly where something went wrong. However, it does have pitfalls that in a number of cases, it won't actually give you an error, and it's up to you to figure out where stuff broke. Like, here's an example that a beginner JavaScript developer might very well write on his own. He'll be like, I can just do add to arrays. What do you think is going to be the outcome of this thing? Not quite. Again, not quite. It's actually going to be an empty string, because that makes sense. Like, type error would have been a better thing. However, we will actually get an empty string. You add an object to an array. Like this is definitely a type error. This makes no sense. You'd want an error at this place. You'd want a stack trace at this place. But you won't get it. And you'll have to debug your variables to see what they hold and what operation is, where did the operation go wrong. What do you think is the outcome of this thing? What it's essentially going to do, JavaScript is essentially going to do, is going to convert both of these to a string. And we saw that an array converts to a string as an empty string, and an object converts to a string as object. So that's why you get that thing there. And of course, like in arithmetic, a plus b is equal to b plus a. But this is JavaScript. This is a programming language. The meaning of addition is driven by the operands. And in this case, the operands reverse. So this is essentially not the same as the previous one. And it's a number, which again makes perfect sense. You'd expect a type error, but it's a number. You add two objects, it gets even funnier, because if I run this through my browser over here, you get this thing, which is what I show here as well, where we've just converted the two objects to strings and added them together. But if you run it through IE, you get not a number, because that makes sense. And of course, once you get not a number, it's going to stay not a number, because not a number plus a number is not a number, not a number star number is not a number, not number divide, not a number is not a number. It's all not a number. JavaScript does have a few good things. For example, the addition of numbers into strings makes perfect sense. Converting a number to a string is something that we understand naturally, and JavaScript supports that as well. You can add negative numbers to strings as well, and they concatenate nicely as well. And we use this to power our user interfaces to show numbers to users all the time. However, anybody want to take a guess what the outcome of this particular expression is? And we've seen, like, once it's not a number, it's going to stay not a number. And your user interface is still going to work. You want to get a nice stack trace, but the user might not understand what happened. And like, you show this to a new JavaScript developer, and they'll probably say that, oh, we have linters. We can lint this. I would, like, you pass this through ESLint, it'll gladly give you an error. But consider this case, where we have an add function. Now, the function on its own is actually perfectly fine. There's nothing wrong with this function. It's how the function is actually being used, which is actually going to be an error. And again, you can say that I can lint this with my linter as well. I just do minor flow analysis. And then I'll show you this example where the variables are coming from elsewhere. And you'll be like, oh, where is it coming from? It's coming from the server. It doesn't matter. It's external to your system. And we deal with external systems all the time. And we want to write safe JavaScript code, which doesn't magically break in certain cases. And that's essentially what TypeScript is. TypeScript is a linter for JavaScript. All the examples that we saw previously, like these things did not make sense to any of us. If you give them to the TypeScript compiler, it'll actually be a compile time error. Now, TypeScript takes any piece of JavaScript code, and I will just go ahead and open TypeScript Playground. So this is on the typescriptlang.org website. On the left-hand side, you get to write TypeScript. And on the right-hand side, it produces the generated JavaScript. Now, the great thing about TypeScript is that any valid JavaScript is valid TypeScript. However, TypeScript adds additional syntax essentially for linting. So here I've gone ahead and said that foo is something that must always be a number, so TypeScript will not let me assign something that is unsafe to it. Everything in this code right now, except for this particular annotation, is just JavaScript. And you can get fancy with your annotations as well. So I can say that it must be something which has a member bar, which must be a number. So then you would actually have to, like if you assign a number to it, it's going to be an error. It must be an object that has the property bar of type number on it. So something like this. Now that's fine. Congratulations, you are now all, if you already knew JavaScript, you now know TypeScript. That's the only syntax that we'll use in this presentation. Let's take a step back and really understand TypeScript's value proposition. It offers two things. First of all, I've said this previously, and I'm going to say this again and again throughout this presentation, that it is just JavaScript with additional syntax. And that additional syntax, so your JavaScript today, the JavaScript next, that additional syntax is primarily for linting. That's all it's there for. And so understanding these two value propositions, a transpiler and a linter, your first question might probably be that why use a transpiler anyways? A lot of you, like the hands that went up in the beginning of this presentation of people that used JavaScript, many of them used a transpiler anyway, so I don't think I need to do much convincing there. What a transpiler essentially allows you to do is to use modern JavaScript syntax that might not be available in all the users' browsers in your code base today. And there are practical reasons for this. The new syntax does help prevent a few bugs and does provide a nice syntax for common JavaScript patterns. For example, for a functional language, you seem to be writing the word function quite a lot. And the next version of JavaScript actually gives you arrow functions where it's a lot less terse. And because you're creating functions constantly, it's a lot easier to do them now. There are other things that actually prevent bugs as well. Like this is a very common programming interview question presented over here, where you give this code to a developer and ask them what it's going to print. So what this code is doing is we're creating a bunch of functions that are going to be stored in an array. We loop thrice, and then we create these functions, and these functions capture the variable I. And then we go ahead and call these functions, so that function is going to execute for each iteration. So coming from C# or Java, you might actually expect that the outcome would be 0, 1, 2, because we created 3 functions with different variable i's. However, the var keyword in JavaScript is function scoped, not block scoped. So the variable I is actually shared between the 3 loop iterations, and you get the same output for each of the functions, which is 333. Like this code, this var I is exactly the same as if someone had written this thing over here. And now it's much more intuitive to see why it's going to be 333. Now you use the let keyword, which is new with the new version of JavaScript. You don't actually get that error because let is block scoped. So that let I is actually going to be a new variable created for each function iteration. And then it's a lot more intuitive to what a C# developer or a Java developer might actually expect the code to be. And we use multiple languages in our day-to-day jobs. So it's nice to have consistency across your programming languages, so you don't have that continuous mental shift that, this is JavaScript, this is too different from my other language. And so the JavaScript purists might argue that we're going to get better JavaScript in the user's browsers anyways eventually, and that's when I'm going to actually use this syntax. I don't need to use this today. And the 2 key arguments against that are that there are going to be new things within the JavaScript specification that are going to prevent bugs. For example, I showed the let keyword over here. And additionally, if you want to keep your skills up to date, it is good to be using a transpiler. And you're going to have to cross this bridge where some stuff runs in the user's browsers, and there's some stuff that is in specification that's preventing bugs, and you're keeping your skills up to date. And one of those bridges is TypeScript. So that's the whole of the transpilation story. The 2 key value propositions for TypeScript were that it's going to give you a transpiler and a linter. Now, as soon as we talk about the linter, the first thing that comes up is the name, the TypeScript, the type within TypeScript. And that starts the whole religious argument about static versus dynamic types. And there are a large number of arguments that people make. One of them is that I have tests. Well, you have tests for most of your code base. It doesn't really, it's good to have tests for things that are syncing. And TypeScript is essentially, linting is a form of testing. another claim is that and tests can be wrong as well. So like this was JavaScript. And the test runner will be like, it's all fine. So you want something more than that, and that is what TypeScript is. Another key motivation for actually having these type annotations within your code base is that it provides better documentation. Like, take this example. This is a very famous function right now, left pad. That if you look at the signature, the types are in the names. Like str, it's a string. Length, it's a number. Like, you get that intuitive thing. It's just that it's not mentioned in any significant way to your transpiler to make sure that no one uses them in a wrong way. And this is perfectly valid JavaScript. This works just fine. However, you don't write JavaScript like this. You actually mention your arguments up front so that the person who's going to read the code is going to understand what the motivation behind the function was. And like I've said this before, you give JavaScript to TypeScript, it's going to happily transpile it for you. The type system is completely optional, so give it to TypeScript, it'll be fine. But you get the opportunity to actually help document your code and essentially make this available for IDEs and essentially testing. Another claim that I hear quite commonly is that I have conventions. I don't need any type annotations. All my users always have user ID. All my users always have display name. So I'm always consistent there, so I don't need type annotations. How are you going to document these? Like, you can write them like this within your docs, or you can actually just add a type annotation, and then your code is self-documenting. So again, TypeScript annotations are essentially documenting your conventions. And there's a lot of pain that people have felt with type systems in the past. TypeScript does not attempt to be the world's most sound type system like other languages. I don't want to mention their names, Haskell. It tries to be convenient in that you write JavaScript code, and it won't make it painful for you like other languages. So this particular piece of code, this is valid JavaScript, and this is perfectly valid TypeScript as well. And like I've shown this before, I'm going to show this again and again before it burns into your retinas. And you can, at any point, annotate any variable as any. And from that point on, TypeScript will be quiet about it. Like, you can write code like this as well, that foo, it can be anything, and you can assign a number to it. You can assign a string to it. You can assign a regex to it. You can assign whatever you can imagine to it. And then you can call whatever function you want to call on it. And if you execute just this piece of code, it's going to fail at runtime. But you told TypeScript to be quiet about it, and it was. So like, if you want to write JavaScript with TypeScript, you can do it all day long, no problem. And another great thing about the TypeScript type system, what makes it different from the other type systems, is that it's structural. How many people here have used AutoMapper? How many of you have had an AutoMapper entry that is just X and Y without any modifications? All right. So you don't need to do that with TypeScript because it's structural. So just because the names differ between the two things, if the structure of the two types is the same, cross-assigning between the types is perfectly fine. The types are purely structural. They're purely for documentation purposes. They do not exist at runtime. They do not have their names impacting their runtime semantics. Another concern that you might have about TypeScript is that we're going to outlive my project. Like, my project is a 10-year project. I don't want TypeScript to die in the middle of it. Well, what framework are you going to use? Are you going to use Angular? Well, that's using TypeScript. Are you going to use Ember? Well, the Glimmer engine within Ember is using TypeScript. Cycle.js uses TypeScript. How many people here have heard of this framework? All right. How many people actually use it? All right. This is written in TypeScript as well, by the way. I had one person raise his hand, and I apologize. Give me your CV later. There is a syntax debate. Like, quite commonly, I raise this, that people are talking about managing their JavaScript code bases. I raise the question that, have you considered TypeScript? And then I'll say that I don't want to learn Scala, or I don't want to learn CoffeeScript, and I don't want to learn Dart or something else. TypeScript is just JavaScript. If you're familiar with JavaScript, all that you're doing is using TypeScript as your transpiler with optional annotations if you want to. Again, that diagram, is it in your retinas yet? And here's a comparison between, like, so how many, this is a simple piece of code that I showed previously. How many people here think that this is valid JavaScript? Like, if I give this code to my JavaScript engine, do you think it'll work? So there is additional syntax over here, so it didn't work. Paste that again. Unexpected token, semicolon, and that additional syntax is that number annotation over there. However, if you give this to Babel today, it's opening somewhere, it'll happily transpile it. And these are just the defaults. I haven't changed anything over here. I did not mean to have that check marked. I guess they have that by default now. That's because the people that make these tools, they understand the value of types. Babel, by default, supports flow types. And this is exactly the same type annotation syntax that you use with TypeScript. However, Babel is very focused on being a transpiler. If you want type checking, you actually use an external tool like Flow with Babel. So over here, we set that foo must be a number, and then we assigned a string to it, and Babel will not complain. That's the job of Flow in Babel's mind. However, you give the same piece of code to TypeScript, and we have seen this before. It'll actually complain that string is not assignable to type number. So TypeScript is your one-stop shop, transpiler, and linter in one. So if you're using something like Babel today, there's absolutely no point not to try TypeScript. You don't have to use it, but just give it a go. And it is like these annotations are all about that linting. TypeScript's key value proposition is not its transpilation. That's a secondary proposition. The main proposition is linting and the IDE tooling that it provides. And when I jump into the demos, you'll see that. So just pick up any library that you've seen out there, for example, like jQuery. This is pointing to the jQuery docs. You can see type annotations everywhere. Like, this is essentially documentation that you have to keep in your mind if you want to be successful with jQuery. Take React as an example. So the React documentation, that has types littered all over it. So render to string is something that returns a string and takes a React element. Code mirror. So how many people here are familiar with code mirror? All right. So whenever you open DevTools in Chrome, code mirror is essentially the code editor, and DevTools crashed. All right. Yep, it's opening up. It's the editor that you see within the sources panel within DevTools. It has one of the best documentations, in my honest opinion. And the reason why is because as soon as you look at this documentation, you know exactly what it's going to take. Like, you know doc.getValue is going to take a separator, which is going to be a string, and it's actually going to return to your string. Like, getValue for a documentation management system, you might think that it might return a lines array to you. But that annotation tells me upfront that it's actually going to be a string. And like, pick your favorite library. Look at its documentation. If you like it, I'm sure its documentation contains types. That's why you like it. Otherwise, you wouldn't be able to understand what does it take, what does it return, what is going on. So with that, how many people here have heard of definitely typed? All right. So this was a project that started in 2012, immediately after TypeScript was released. And what they've actually done is they've gone ahead and added documentation that can be used by TypeScript for all the major libraries out there. For example, let's just take a look at the documentation for jQuery. Now, this is like that all the stuff about jQuery that you would have to keep within your brain if you wanted to be sure that nothing would go wrong with jQuery. And then you'd actually have to pass someone else's commits to your code base and review them and make sure that they're using jQuery the way it's meant to be used. So with that, it is by Microsoft, but it's the new Microsoft. So it's all open source. I'm running it on a Mac. It works everywhere. It's just JavaScript. It's written in TypeScript as well, which is, again, just JavaScript. So are there any questions at this point? All right. Let's just jump into the demo. So So over here, I'm just going to go ahead and open a JS file. Can you see the file back there? Can you see it now? Can you see it now? All right. So this is a JavaScript file. It has a bunch of errors in it. They are intentional, but the key thing that I want to point out is that it's hard to review. Like this is a JavaScript that you'll have to review from the new developer. You see up here that object or defined property is being called. Does anybody see anything wrong with this line beyond the fact that the new developer is adding stuff to window? That's because you're not expected to memorize the signature of object or defined property completely in your brain. However, TypeScript already contains the definition for this particular thing and the kind of structure that it expects. And it's going to go ahead and point out that read only is not something that you add to defined property. What is something that you add to object or defined property? Well, let's just leave this and let TypeScript auto-complete it for us. Well, writable sounds like something that the developer might have wanted to use. And now it's fine. Being a non-native English speaker, I don't even know how to spell writable correctly. So it's nice that I don't have to. All of this stuff that the JavaScript runtime has, I don't have to have it in my brain. It's all being linted for me and being auto-completed for me. So I can focus on my actual application. I can understand that delivery method, what it does. That's more significant to me than understanding the browser idiosyncrasies and the exact semantics of the browser API and making sure that no one actually uses it in a wrong way. So here's another error over here. Does anybody know what the error is within this line? The error is that parseInt actually goes ahead and takes a string. However, document.getElementById returns an HTML element. The developer probably wanted something like text content, and then so that's a string, and then that's what they wanted parsed or something like that. That's just, and like this is another example which very well might not actually fail at runtime, and actually might give you a nan, where they actually meant to use the binary OR instead of the bit OR operator, which is like, this is quite common way of getting a default value from something. And that fixes the error that TypeScript caught up front. But if you look within this file, send updates, it has a comment. It says that email address, an email address or an array of email addresses to ship with. Now that's something that you want to document in your code. Like if you were writing good JavaScript, that's what you would write anyways. But what you can do now with TypeScript is that you can actually go ahead and document this for the compiler as well. You can say to the compiler that make sure that anybody who calls this function passes me a string or a string array. You don't have to read this particular comment and pass the meaning of that within your brain. Once you become familiar with the TypeScript syntax, it becomes much more natural. And what's going to happen over here is that TypeScript is going to actually figure out that the function body conforms to this structure as well. If you think about it, the function signature, that's just a theorem, and the function body is the proof of that theorem. Like if I go ahead and annotate that something must be a string, that this function must return a string, TypeScript's going to actually essentially do a test on the function and make sure that it returns a string, which in this case it doesn't. So with that simple annotation of converting that comment to a type annotation, TypeScript is going to go ahead and figure out that there are misusages of the parameter within the function. And over here, does anybody know the error? Like, why would this not work? Like, this sounds like a perfectly valid comment. If it's an array loop over it, that's duck typing. Like, why would that not work? Does anybody know? Yep. And TypeScript's gone ahead and figured that out. So, like, a proper way to discriminate between a string and a string array with ES5 is this method. So, array.isArray. So that would actually go ahead, and within this block, there is no way that email address cannot be an array. So TypeScript is going to go ahead and figure that out, and it's going to figure out that email address must be a string array. And there's an else over here, and TypeScript is going to go ahead and figure out that within this block, it must be a string, because it's not a string array, because that's in the previous block. And then you get more errors within this code. Does anybody know the error over here? Yes. That's the error here. Thank you for that. This is why I use TypeScript in demos. Does anybody know the error here? No? So the issue is that it's actually val, comma, index. That's the signature of for each. And they were swapped around. So what was happening was that IDX was actually the string, and val was the index within the for each. So this is something that a junior developer might very well write, and we've just seen that. If they push this, you'll be like, OK, let's just push this to production. Let's make it a testing problem. Well, you can add type annotations and just fix it there, and then you don't even have, this is essentially code coverage for this particular block that if you write test for it, that test is only going to get saw and become a nightmare to maintain, because if you want to change something, you have to change the test, and then you have to justify why did you change the test? Why did you delete the test? Because it wasn't working. You should have fixed the code. With TypeScript, it's much more natural. So that's just a quick demonstration. Does anybody have questions about this particular thing? All right, lovely. Let's jump to the next one. So what I am going to do now is I have a very simple React app written in TypeScript. So how many people here are familiar with React? All right. So that number is a bit low, so 3 people. Everybody does know React, but you might not actually know why React is awesome. So the reason why React is awesome, let me just, before I go there, let me just explain the setup and just show you exactly how simple the setup is. So you just initialize an npm module, so npm init, you get this package.json, npm install webpack. So you bring in webpack into the project, and then within start, I have webpacks -- watch. And what that's going to do, webpack's going to pick up a webpack.config in the same folder. And the webpack.config is even simpler. We have an entry point for our application, and then we have an output bundle which webpack is going to generate. And we then tell webpack that just take, if a module resolves through a TS or TSX, transpile it with TS loader. So that is essentially copy paste. I don't imagine how that can be any simpler than that. We have a very simple index.html with that, which is actually just going to go ahead and load that bundle.js. And then we have our app.tsx, which is the main entry point for our application. So with that, if I go ahead and in a separate window, just run npm start, that is going to go ahead and run webpack in watch mode. Cool? So that's blindingly easy. I'm just going to go ahead and copy the path to this HTML file. I don't even need a server. I'm just serving this HTML file to the browser directly. What I will do to prove that this is that file is just I will console.log, hey, NDC beeps. And you'll actually see that logged within the console. Cool? Now, the reason why React, I'm a big advocate of React, is that it's just JavaScript. Here's an example of something that is coming from React. So I'm just going to go ahead and have a div with hello world inside of it, and I'm going to go ahead and console.log. Now, this syntax sort of scares a few people. And it's essentially very similar to something like, so let me just show you what it logs out. You'll actually see that it's just an object that's being created. Nothing fancy about it. It's essentially very similar to something like console.log. Something like type is a div, and then it has some props, which has some children, which is hello world. That's all that is. The 2 objects that are going to get logged out, they're very similar. It's just syntactic sugar on top of that. But the great thing of using this is that it allows you to use all your JavaScript tooling for maintaining your HTML stuff as well. So you can have a cohesive story for an application with just one programming language. And TypeScript supports it out of the box. All that I've done over here is created a TypeScript config file and just told it that for the JSX syntax, go ahead and convert that to the React version of transpilation. So that's very clear. That's just an object. And then what you can do with React is you can actually go ahead and ask it to convert it to any format. For example, I can go ahead and convert this object into something that you can set as an inner HTML for something. So I'll just go ahead and bring in React DOM server, and I'm actually going to go ahead and React DOM server dot render to string. So I'm just going to go ahead and store this in a variable. Foo is equal to this thing. Done. Console log foo. You saw this before. I'm just going to go ahead and render foo to a string as well. So now, if I go ahead and run this, you'll actually see that it generates a nice div that you can potentially set as an inner HTML for something. In addition to rendering to a string, you can actually have React render to some element within your DOM as well. So within our index.html, we just have this one div with an ID root. I can get a handle to that div quite easily with document.getElementById root. So if I just log that out, you'll see that div logged out. That's fine. What I can do is ask React to render foo to that div. And now you'll actually see hello world being shown up as a div. So are there any questions about that?
So using TypeScript in React means there will be two levels of compilations. One from TypeScript to JSX, from JSX to...
No. So the great thing is that it's this JSX that you see over here. It's within a TSX file. So it is it's the JSX syntax plus the TypeScript syntax supported in that as well. And the only transpiler that you need for this is TypeScript. You saw the webpack.config. There is no Babel reference over here. It's just TS loader. So for any TS or TSX files, you told TypeScript to use Webpack to use TypeScript, and that's the only transpiler that's in action over here. Yep. So this is something that is very similar to something I mentioned previously, that if you give a JS file with type annotations to Babel, it will happily transpile it. I'm not a big fan of that. I'd like to have my JS files only contain JS syntax. Doesn't matter if it's ES-next syntax. That's totally fine with me. But I don't want non-standard tracked ES syntax in a JS file. That's why I prefer to have that syntax in a TS file and use something like TypeScript instead of something like Flow. Additionally, with JSX syntax, it's quite common for people to actually put that in a JS file and then just pass it through Babel with that conversion as well. The TypeScript team has gone with the decision that because it's actually different from TS as well. So TS, the main motivation for TS is having type annotations. The main motivation for having TSX is to have type annotations and JSX supported. So that's just like, so now you can go ahead and update your resumes on LinkedIn that you know React. What you can additionally do, because it's just an object that's being passed around, like it's very easy for me to convert this to a function. So this is a function that returns that div. So now I actually have to go ahead and call that function, and you can see that it still works fine. Now with that, you can actually have the function take parameters as well. So I can just go ahead and say that it is something that has message inside of it. Now because it's TypeScript, it's going to pick up the fact that within your code base somewhere you're actually calling this function without passing in all the objects. So it's going to enforce you to use message over here, which must be something. So I'll just go ahead and say hello NDC, and I'll actually go ahead and use that within my component as well. So now if I run this, you can see that essentially what I've done is I've actually created a React component without ever actually creating a React component, because it's just JavaScript. Well, you can take this further, and that's what the original sample was. We just go ahead and take two properties. So I'm saying that properties is something that must have a compiler of type string and framework of type string. And then when you go ahead and, so I could very easily do this as well. Hello. And as soon as I do this, it's a function that takes two properties. TypeScript is going to complain. It's going to say that it must have a compiler, which is something, and then it must have a framework, which is something else or whatever. And this would work perfectly fine as well. However, what I am converting this particular function call into JSX syntax is going to do is I'm creating, again, an object instead of actually creating a function. I'm telling React that render the hello function with these particular properties. So I'm not actually immediately invoking the function. I'm just giving that object specification to React, and then React is going to render it when it needs to. So that's all that JSX is a better way of creating an object. You can write that object yourself if you want to. It's just more painful. Now, with that, so you could use Pebble with this as well. That you wouldn't get a discriminating experience there. But if you use TypeScript, what you actually get is compile time safety. So for example, if you go ahead and misspell something over here, you're going to get an error that our compiler is not a property that this particular component accepts. If you misspell the component name, TypeScript is going to complain, this variable is not defined. I don't see any hellos over here. There's only a hello. Maybe you were meant to use that. And then additionally, the types are checked as well. So if I go ahead and say that compiler must be a number, and if someone calls that wrong, TypeScript is going to go ahead and complain that you're trying to give a string to a number. You're probably making a mistake there. So it's really about that agility of your developer tool. It's really about developer tooling. TypeScript's key value proposition is the linting and the type checking for your code. Now, additionally, what you can do is like, has anybody ever tried to rename stuff in the JavaScript? Did you enjoy it?
When I was using TypeScript, yeah.
Okay. So yeah, with TypeScript, the experience is something like this. So if I just go ahead and fix my compiler error, I can go ahead and rename compilers to something else, and it just works. So you can get the non-native English speaker to name their variables, whatever makes sense to them. And then when the code comes to you, you can say, oh, I'm actually just going to rename this. Don't worry about it. I'll merge this myself. You can go home now. Whereas with JavaScript, you're like, can you please rename this to the standards that I'm following? Because I can't rename this. It's going to be a nightmare. And then send it to me again, and then I'll look at it. So that's the beauty of TypeScript. Any questions about that? So it's within the TypeScript project. So over here, we have a tsconfig.json, which is including everything within the folder. And the folder actually only contains one file app.tsx. Yes, definitely.
Is there anywhere that I can have most frequent after that type definition file, so that without not downloading that after the file, because it's going to override from me?
Yes, so that does exist, and that is what this particular project was set up to do. So you can see typings install. So if you run npm install on this project, it'll go ahead and install the latest typings for you. So sorry, it will just install the typings. You can add a new one, which is like some npm script that typings minus update, and it'll do that. That said, the key thing that you should keep in your mind is if you don't have type definitions, your experience is very similar to what a JavaScript developer's experience would be. So any pain you feel in bringing in typings is essentially the pain of bringing in any documentation. Like, I'd rather have that documentation and go through that pain once and then not have to worry about it and keep it in my head than having to memorize the whole of the jQuery API and then keep it in my brain at all times. I'd like to think of higher order problems than that. So that is that. Like, because it's all statically analyzable, you get other things like find references as well. So what are all the references of this particular thing? This is essentially like find references is simpler than rename, so it's nothing fancy to show there. Now, the next demo that I'm actually going to jump to is the experience of converting a JavaScript project to TypeScript. How many people here have heard of Vue.js? I see nods, I like to see hands. So a number of you have heard of it. It's one of the very popular frameworks out there. It's written in ES6. Now, because I've been showing this continually that TypeScript is just JavaScript. You can give it a JavaScript file and it will happily transpile it for you. I'm just going to, as a demo, open up the view source code within my IDE. Now, this is the directory for Vue.js. So you can see that there's nothing up my sleeve. I am on the dev branch up to latest. There are some files, and I'm curious, why are there unsafe changes? Yep, so that's just when my IDE booted up, it added a session file. So nothing up my sleeve. It's all just the Vue.js source code vanilla. Now, at this point, there is no TypeScript within this code base. This code base is massive. It has a lot of JS files. And you might be worried that this is something that your project might look like, and you might want to migrate to TypeScript. The first thing that you're actually going to do is go ahead and create a tsconfig.json. And a tsconfig.json file is just essentially you telling the TypeScript compiler the source code of your project and the configuration options. And it's actually very easy. All that I need to do within my compiler options is just tell it that allow JS, because I have a JS file, a bunch of JS files within my project. And then as soon as you do that, because it's going to have to transpile them, it's going to have to move them from some source directory to a destination directory. I see that there's a dist folder here. So I'll just go ahead and specify an out dir as well as the dist folder. And then I'm going to tell TypeScript all the files that are to be included within my project. And all the source code seems to be inside the source folder. It isn't. But let's just go with that assumption. So source, get every start.js from that folder. And because I'm actually going to be migrating it to TS, I'm just going to go ahead and a TS as well. So that's like, I couldn't make that configuration any simpler than that. I'm just going to go ahead and tell TypeScript that this is the project that I want to work on. As soon as I do that, you can see that the source folder lights up. So these are all the files that are now within the TypeScript compilation context. And you can see that there are actually no errors within this project, because this was valid JavaScript. TypeScript took that valid JavaScript and gave back valid JavaScript. It will not complain for .js files. Now, if I just jump into index.js within that file, I can actually go ahead and see whatever transpilation TypeScript is actually going to go ahead and do for this file. So for example, I can go ahead and say let foo is equal to 1, 2, 3, and then TypeScript is actually going to go ahead and transpile let away from me and convert it into var. I can go ahead and say that foo is something that is a function that always returns a null, and TypeScript is going to go ahead and convert that arrow into a function that always returns a null. So you can actually use TypeScript as just your transpiler. But the key thing about that is that JavaScript has very low semantics about what is and isn't. So it's essentially doing a syntactic check, but it's not putting any restrictions on your code base, which means it cannot provide guarantees about the quality of tooling that you get. And this is essentially like if you open up JetBrains, and like if you have some variable foo over here, and then you have some variable bar over here, it will happily provide autocomplete that maybe you wanted bar.foo. Like, no, foo is a number. Why would you suggest that as an autocomplete for bar? But that is the kind of JavaScript tooling that you get in any IDE out there. And that's, so this is using TypeScript code intelligence for JavaScript files. This is code named Salsa, and you'll see this mentioned in a number of other tools as well. You'll see that in Visual Studio. You'll see that in VS Code as well. But this is the experience that you'll get if you're using code intelligence for pure JavaScript files. What you can do within the same project is I can go ahead and add, for example, a bar.ts file. And now when this file gets into the TypeScript compilation context, here's an example. So if I go ahead and define a function over here, and I specify that the function always takes some argument, TypeScript will not let me call this function without an argument. Why would you have a function that takes an argument and not call it without an argument? It makes no sense. So it's going to force you to have that. However, within JavaScript, people write this code all the time that they have functions that when they take optional arguments, because there is no way of annotating it, TypeScript will not hurt you for using JavaScript. It'll try to help you as much as it can, but it cannot provide static guarantees that you actually get from something that is designed to be statically analyzable. So if you want something that is optional, TypeScript will actually force you down the path of having that as optional. And this is something that people run into when they think about TypeScript. They open up a TypeScript file, they start writing code, and then TypeScript starts screaming at them that this is unsafe, and then they say, this is valid JavaScript, I'm going to move to a JavaScript file. But the pain that you're actually feeling is the pain you're going to feel at a future point, or the next person is going to feel after you've left. So that's that. But you can actually mix and match them quite easily within your project as well. So I can go ahead and export this function from that does nothing from this bar.ts, and I can actually use this quite easily within my JavaScript file as well. So I can go ahead and import from bar. Let's just bring in the function bar and just call it. All good, perfectly fine. I just mix-matched TypeScript and JavaScript in the same project. Not a problem. You can convert Vue.js to JavaScript to TypeScript in 1 second because you just need a tsconfig file. You can do that with any project. If it's valid JavaScript, it's going to be valid TypeScript. What you will not get is stuff like if I have. So I heard. Did anybody have a question? All right. So I saw a hand go. Just doing this. So if I just go ahead and have something that isn't valid JavaScript within a TypeScript file, TypeScript is going to complain that, that's not a valid variable number. What are you doing? This is a JavaScript file. So you do get syntactic errors type checked by TypeScript. Type checking, you do get some of it, but you don't get it to the extent that you'd expect, primarily because it doesn't have that guarantees. And there are other, so the great thing about TypeScript is that there is a slider that you can move as far as you want. For example, I can be a bit more strict about my code. I can say that no implicit any. Don't let, and if it's not analyzable, don't let me do that. And you can see that an error shows up over here. This function, there is no way for TypeScript to figure out what the type of arg is. It can be anything. That's essentially something that you've left undocumented for the next developer as well. But now TypeScript's actually going to complain and force you to say that, I cannot infer the type of this. What did you mean? Well, I meant a number, so just go ahead and do that, and the TypeScript will be quiet about it. And there are a lot of other flags as well. For example, you can say that no unused parameters. And if I set that as true, you'll actually see that, so you defined arg, but you never used it. Did you mean to do that? Why would you do that? Is that to confuse the next guy? No. So I actually didn't mean to use it. That's why, sorry. My bad. All good.
Do I have to mention this? I thought that by default, all these rules are true.
So what the TypeScript team is doing? So they went from having a very JavaScript experience for everyone to be a very strict experience for those that can afford that luxury. If you go into a new team and you tell them that please use TypeScript for your JavaScript, they'll be like, I don't like types, and then you'll say you don't have to use them. And that'll work. That's the default experience that you want. Because it is your JavaScript. TypeScript is focused on making your JavaScript the best experience out there. So if you want a different experience, you have flags to switch them on. You have to know, and essentially this is something that other transpilers flow. They'll actually give you more errors, and then they might actually confuse you. Whereas with TypeScript, you actually understand the type system before you can actually use it. Yep.
Those flags you turned on, are they part of the JavaScript logs?
Some of them are. So you can see that there are 7 errors that have started to show up. So that's. No. So those aren't. So that isn't. That's just the syntactic errors that have. Many of them do, because you don't have the opportunity to mention an optional in JavaScript, right? So forcing you to be explicit about your arguments, that's not something that your JavaScript is going to be able to migrate to. So if you want the best tooling experience, best linting experience, you go over TS, yeah?
But weren't you writing TypeScript in this file before?
No. So I wasn't writing TypeScript, I was writing JavaScript. So this let foo is equal to something that is just JavaScript. If you go ahead and annotate it like something that is like this thing, you'll actually see TypeScript complain that you cannot use type annotations in a JavaScript file. And that's what you want. You don't want a .js file with TypeScript inside of it. So if you're concerned about TypeScript getting all up in your JavaScript, don't be.
But one of the issues that I faced that some of the teams that they don't want their all JavaScript files to be converted to .ts file. So that .ts file will then again go by a transpile into intermediate JavaScript, which is actually not written by a human, it's written by the
Yep. So for those things, like you can still keep this separate. So a key example of that would be like if you have jQuery within your project, you can actually go ahead and do this thing. So right now, so within like this JS file, dollar isn't something that's actually going to show up as an autocomplete thing. Whereas you can go ahead and declare within a .d.ts that there is something called dollar that has, let's just say, the method Ajax on it, which is anything. I don't care to annotate that right now. But then you actually get to use $.ajax and all that autocomplete. And then additionally, so this is essentially documentation for a JS file out there within your project or within someone else's project, in this case, jQuery. You can actually use that file within here immediately right now. Like if I go ahead and comment out all of this, .d.ts documentation for a .js file, I can, at this moment, not use dollar. However, if I go ahead and document my JavaScript, I can actually use that within a .ts file, and actually this error will go away. And it does. And you get nice .ajax completion and all that thing. So you can have like, you don't, if someone says that I don't want you writing, I don't want to convert this to a .ts file, you don't have to document that in a .d.ts file right next to it. All right, that seems to be the end of the questions. So the key takeaway is that, like, it's just helping you. It's just JavaScript. And the IDE that I've been using today, that's all written in TypeScript and React, and that's all open source as well. And I have a free book on the subject as well. So, like, I love helping people. That's my life goal. When you're going out, please leave a green card. That would really help me a lot.
What are you doing tonight?
So yes, I am presenting at NG Sydney about exactly how all the features that exist within this developer IDE. So please join us if you want to.